Okay, so this is part 2 to the video you just finished watching. So let's consolidate basically what we just learned. So in general, if at least one item is chosen, so that already omits the null set. If we're choosing at least one item, if we're creating a subset that has at least one item in it, so not including the empty set or the null set, the total number of selections that can be made from P items of one kind and Q items of another kind and R items of another kind, etc., is P plus 1 times Q plus 1 times R plus 1, ... take away the null set. Now, the only reason there's a ... is because we don't actually know how many different items we'll have. Just like in the previous question over here, the reason why we only did it twice is because we only had 2 sets of identical things, pennies and nickels. But if I had 3 pennies, 2 nickels, and 4 quarters, then we would have pennies plus 1, nickels plus 1, quarters plus 1. Okay? So that's why it's a ... So each of the PQR just represents the number of different items you have. Okay, so now it says predict the number of different selections that can be made from 4 pennies, 3 nickels, and 2 quarters. Okay, I didn't even know I was about to read that. Okay, so 4 pennies, so 4 plus 1, 3 nickels, so 3 plus 1, and 2 quarters, so 2 plus 1. Take away the null set, and I end up with 5 times 4 times 3. Take away the null set. It's going to be 60 minus 1, so 59 selections. Okay? Okay, so now we're kind of just putting it into practice. It says, example 8, the difference between a subset question and a combination question is under example 8. So, A, this is, let me indicate this with something. 8A, this is a subset question. And B, this is a combinations question. Okay, so what you do here is it says for A, I have 20 different hockey cards. So they're all different, they're distinct. How many selections can I make if I have to pick at least one card? So it's vague. Selections, how many selections can I make? I can choose one card, I could choose 2, I could choose 3, I could choose 4. It's not specifying how many cards I have to pick. So it's asking me basically, how many different subsets can I make? How many different subsets can I make, excluding the null set? That's basically what it's asking. Okay, so we go, okay, well, I have 20 options, and I know my sum is similar to Pascal's triangle, so 2 to the 20 minus 1, right? If we go back to the first page here, it says there are 2 to the n, here it is, there are 2 to the n subsets possible chosen from a group of n distinct objects, including the null set. If we're excluding the null set, we do 2 to the n minus 1. So here, our set is 20 items. We want to know how many different subsets we can make. Well, we can make 2 to the 20 subsets, but we're not including the null set, so we take away 1. And we get 1, 0, 4, 8, 5, 7, 5. Now, the reason it's not a combinations question is because if it were a combination question, I would have to do, okay, how many ways out of the 20 cards can I choose 1? 20, choose 1. Or, or means plus, or of the 20 cards, how many ways can I choose 2? Or of the 20 cards, how many ways can I choose 3? And so on, all the way to 20, choose 20, and no one wants to type that into their calculator. Okay, so then you would just do it like this. Whereas for B, it says, I have 20 different hockey cards. How many ways can I choose? Exactly 5. They've told us exactly how many we want to choose. So then we go perfect. Out of my 20 cards, I want to choose 5, and I get 15,504 ways. Okay? And then lastly, we have Susan has 4 mystery novels, 3 biographies, and 4 nonfiction books. She wishes to select 3 books to take on her holidays, but she wants to have at least 1 mystery. So at least one of her 3 books needs to be a mystery book. How many different selections could she make? Okay, notice selections is a key word for when it's a subset question. Okay, so we have 12 books total, right? 4, 3, and 5. We have 12 books total. Okay, we have 2 methods we can do here. We can do the direct method, which is always more annoying. And we can look at cases. Direct method deals with cases. So we have case 1. Case 1 is when we only have 1 mystery novel. Because it says, how many different selections can she make? Because she wants to have at least 1. At least 1 mystery novel, which means her selection of 3 books can have 1 mystery novel, can have 2 mystery novels, or all of them can be mystery novels. So case 1, I only have 1 mystery novel. How many different ways can I do that? Well, that means of the 4 mystery novels, I'm choosing 1 of them. And of the 8 other novels, because I have 5 nonfiction and 3 biographies, of the 8 remaining novels that are not mystery novels, I'm going to choose 2 of them because I'm only taking 3 books. So if I'm choosing 1 mystery one, I need to choose 2 other books, and that would give me 112. Case 2 is if I have 2 mystery books in my 3 books, which means of my 4 mystery books, I'm choosing 2, and of my 8 other books, I'm choosing 1, which give me 48 ways. Case 3, let's say all 3 of the books that I choose are mystery books. Then I'm saying of my 4 mystery books, I'm choosing 3, and of my 8 other books, I'm choosing none of them because I can only take 3 books. That's all I want. There's 4 ways to do that. Okay, so I have a total of 112 plus 48 plus 4, which equals 164 ways. Now, the reason I didn't do a case 4 where I choose 4 mystery novels is because they told me she wishes to only bring 3 books with her on her holidays. So I can't bring 4 mystery novels if I'm only bringing 3 books. Okay? Now, my alternative is the indirect method. And I'm going to go, okay, total number of ways to bring 3 books minus the number of ways I bring no mystery books at all. If I bring no mystery books and I take those options out, I'm left with only the ways where I've taken at least 1 mystery book. Okay, now when I do that, I'm left with, okay, of my 12 total books, I'm choosing 3. That's just the total number of ways to choose 3 books out of my 12. And I'm taking away the ways that I've gotten no mystery books. So 4 of my mystery books, I'm choosing none of them. And so I'm multiplying. Of my 8 remaining books, that's where I'm getting my 3 books from. Okay? So that will total 164 ways. You also don't need to write this part here. You could just write 12 choose 3 minus 8 choose 3. Okay, but some people do prefer to have, okay, well, 4 mystery novels and I'm choosing 0 of them as a visual. Okay, so that's how to do that one. Now on the back here, it just gives you a summary of what we're looking at in terms of combinations and permutations. So we're talking about order mattering. With permutations, we know order matters. We're arranging R out of n distinct objects, and we use NPR. We also use arrangements where some objects are alike, so we divide out the repeats, so we know that. Okay, with combinations, order does not matter. We're selecting exactly our items from n objects, and we're using n choose r. And then here, we're also, the number of selections is not defined exactly, so we can use 2 to the n minus 1, or we can use this equation here that we learned. Okay? Now, in the next page, it looks like this. I will upload the solutions to this to Brightspace if you are curious. They're kind of like proofs and using the formula to kind of prove that the left side equals the right side, or you're solving for n. Okay, so that's kind of what the rest of the lesson looks like. Now, we're not going to do this, and I'm not going to evaluate you on this, but I will upload the solutions to Brightspace in case you want to have a look. Okay, so that's all we're doing for this lesson. And then I will see you all tomorrow. Don't forget, you have our quiz on Monday. Okay, so I'll see you all tomorrow and continue working on shading in your Venn diagram.